Okay, I've started recording for the meeting. We're going to go ahead and start class. I wanted to start kind of with a review of the quartiles. That was the last thing on your PowerPoint lesson, and I just wanted to go over a few more things with the quartiles to be sure you had all the concepts with that. So I'm going to switch over to the note side so we can go over a couple of examples with the quartiles, and hopefully that will be a little bit clearer for you. All right, everybody seeing that screen? Yes, no? Is everybody seeing that screen?
It's a little blurry, but I can see that there's supposed to be a paper there.
Is that cleared up any? Is that cleared?
Yeah, I can see it just fine.
Okay, good, good, good. All right, the concept of quartiles, if we were looking at a data set, if this line represented your data set, of course you have your minimum value and you have your maximum value. And what quartiles does is to divide your data set into 4 parts. So the middle value is your quartile 2, which really is the same thing as your median. So it divides your data in half. And then quartile 1 divides the first half of your data into 2 equal parts. And quartile 3 divides the top half into 2 equal parts. And that's how you get your 4 equal parts of your data. So each of those parts represents 25% of your data. Now that's important to know because sometimes you'll have questions about talking about the percentage of your data. So we talk about the top 50% of your data. That's represented by the median or your second quartile, the top 50% of the data. And you know that based on knowing where the median or the second quartile is, or the lower half of your data, which again is based on knowing where the second quartile or the median is on your data. So you can talk about your data based on knowing that information. So the top half versus the lower 50% or top 50%. We might need to know the top 25%, which means we then know the lower 75%. Or we might need to know the lower 25%, which means we also know in reverse the top 75% of the data. So you use those percentages to help you analyze different aspects of those percentages about your data. And then you use that term IQR, which means you take the third quartile minus the first quartile. To find a specific amount. And then we use that to help us find whether we have outliers or not. In our data. So let's look at a specific set of data.
That's my advisor. Yes. She got my fucking name, I swear to God.
All right, if we looked at the speed of some vehicles in a construction zone, and I've already put them in order from least to greatest. So we have 20 miles per hour, 24 miles per hour, 27, 28, 29, 30, 32, 33, 34, 36, 38, 39, 40, and then 60. So all of these values represent the speed of the vehicles in a construction zone on a highway. So the first thing you would do is you'd count up how many values do you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 values, is that right? Can I count right today? So 14 values. If we were going to find the second quartile or the median, that would be the middle value. Is there a middle number when you look at that? Somebody waiting to get in? Is there a middle number when you have 14 numbers? No. So how do you find the middle number? You take the two numbers in the middle and you do what with them? You add them together and you divide by 2. So which two numbers are in the middle? The 7th and the 8th one. 1, 2, 3, 4, 5, 6, 7, and 8. So you're going to take these two numbers, add them together, 32 plus 33, add them together and divide by 2. What do you get? Who has an answer?
$32.5.
Yes, 32.5. That value is quartile 2, which is the median. So we took a set of data that had 14 values in it. You do not have a middle number. So in order to find the middle number, you had to take the two that were in the middle, add them together, divide by 2, and that gives you your middle number. So that is your quartile 2. All right, so now 50% of your data is above it, 50% of your data is below it. So that's what we know about the median. That's what it does to your data. It divides it in half, 50% above it, 50% below it. All right, now how do we find the next quartile? How do we find the quartile below it? We take all the data that's below it and we look for the quartile in the middle. What's the number in the middle? Where there's 7 values here, is there a number in the middle? Yes. What number is in the middle of those 7 numbers?
28.
28. So that number is going to be quartile 3. Excuse me, on the lower side, that's going to be quartile 1. We do exactly the same thing on the top half. There's 7 numbers, so the number in the middle would be which one? Seven numbers.
38.
38 would be the number in the middle. So that would be quartile 3. Now we've divided the data into 4 parts. This is the lower 25%. This is together the lower 50%. This is another 25% here, and this is the top 25%. So by finding the quartiles, we've divided the data into 4 parts. All right, so that's what quartiles do to our data. Now, from that information, answer a question. How much of our data is less than 28 miles per hour? Can you give me a percentage? How much of the data is less than 28 miles per hour? Can you answer that question? 28 miles per hour lands at what quartile? The first quartile. So what do you know about that percent? If it's at the first quartile, what percentage is that?
25%.
25%. So what percent of the data is less than that miles per hour? We would say that is 25% of the data. What could we say about the percentage that is less than 38 miles per hour? So if we find 38 miles per hour on our chart, that is at what quartile? That is the third quartile. So what percentage of the data is below that amount? That's 3 of them. So what percent would be less than that?
75%.
75%, exactly. If we turn that around, what percent would be greater than that? So what's on the other side? What percentage is greater than that?
25%.
25%. But what I'm trying to get you to see is by knowing quartiles, what are some types of questions that can be asked about the data based on knowing those percentages? Do you see the types of questions that can be asked about the data just by knowing quartiles and the data? Do you see that information? Okay, suppose I had greater than 32.5 miles per hour. What would you say about the percentage there? That would be what? What would that would be 50%. So if you know quartiles, you can use percentages to help you answer certain types of questions about your data. Now, can you give a 5-number summary? So that's knowing some of that terminology that was in your presentation from over the weekend. The 5-number summary. What information are you given about your data if you're given a 5-number summary? You're given the minimum value. What's the minimum value? What would it be? 20. What else do you give in the 5-number summary? You give quartile 1, which would be 28. You give quartile 2, which would be 32.5. You give quartile 3, which would be 38. And you also give the maximum amount, which would be, in this case, 60. What kind of visual can you make when you know a 5-number summary? The visual that you can make from a 5-number summary is a box plot. So that presentation goes into how you create your box plot if you know your 5-number summary. So this is a presentation that you can create when you know that information. Now, you can also find outliers. An outlier is an extreme value that might be in your data. Now, sometimes you just kind of guess if you have an outlier, but there is a way to determine if you specifically have an outlier in your data if you have your 5-number summary and you have quartiles, and that is to use your IQR value. So how do you find your IQR? You use your 3rd quartile minus your 1st quartile. So in this case, we would use 38 minus 28. And what is the IQR? For this set of data, the IQR is 10. And then we're going to calculate 1.5 times the IQR. What value does that give us? 1.5 times the IQR. How much is that?
$15.
15. Thank you. Now what we do is we take the first quartile and the third quartile, and we're going to find what we call a fence. So we're going to take this value and we're going to find the upper fence by adding that value to the third quartile. So the third quartile is 38 plus that amount. What does that give us?
$53.
53. And then we find the lower fence. And we take the first quartile, 28, and we subtract that amount. What does that give us?
$13.
13. Now, when you do this lower fence, sometimes it's possible to get a negative value. Don't let that throw you off. It is possible that the lower fence goes into the negative values. So that is a possible answer for the lower fence. But when we look at these fence values and we look at our data values, do we have data that is smaller than our lower fence? No, we don't. Do we have data that is bigger than our upper fence? Yes, we do. So if we have data that is outside of those fences, then we have an outlier. So do we have an outlier in our data? Yes. So we have an outlier that is 60. Because it is beyond the fence. So we use that IQR value to find that fence, and then we positively know that we have an outlier because it is either below or above those fence values that we calculated. And then in your presentation, it talks about creating a modified box plot. And the modified box plot draws the whiskers to the fences, not to the end of the data, but it draws the whiskers to the fences, and then it only uses an asterisk to show where the outlier is. So it doesn't draw the whisker all the way out to the data value of 60. It stops where the fence is and then uses an asterisk for wherever the outliers are. That's the difference between a modified box plot and a regular box plot when you're creating those. So I just kind of wanted to go back and look at that. I think for the most part, all of you have heard about central tendencies, and so I felt like you could probably go through those notes and review those and be able to calculate those on your own as far as mean, median, and mode. You've heard them enough, seen them enough. You were okay doing those on your own, but I thought you might need a little bit of extra help with the quartiles and the box plots. So did this kind of help with that part a little bit? Yes, no, did it help a little bit? Do you need me to do a box plot for you? Would that be helpful to do that with you?
Yes, please.
Okay, I'll be glad to do that. All right, let's continue with our same data. So we have our 5-number summary. So to create a box plot, you would create a number line. So you want to create a scale on a number line. You can do a vertical number line or you can do a horizontal number line. It does not matter which that you use. I typically use a horizontal number line, but it is really up to you which that you use. You want to look at your highest value and your lowest value. So we're going from 20 to 60. So you want to think about your scale. 20 to 60. What would be a good scale to go from 20 to 60? If you went by ones, it would be very long, would it not? So what would be a good scale to use to go from 20 to 60 on that number line? If you went by fives, it might be too compact. But fives are not bad. So let's just kind of do that. So we're going to start at 20. And we're going to go 25, 30, 35, 40. You do not have to label every single unit. 45, 50, 55, 60. And you should have the spaces even. Mine are not quite even, but you want to make them as even as possible when you draw them. You certainly don't want one real close together and the other one real wide, but try to make them as uniform as possible. I'll give you a moment to get yours drawn. Notice I've left some space above my number line so I can draw my box plot above it. While you're drawing that, I'm just going to check and see if anybody's trying to get into class. I haven't seen anybody else pop up.
Hey, Ms. Burden.
Yes.
Austin is trying to get in, but he says none of the links are working for him. Like, it's not giving him an option to not download it and just come straight into the meeting.
Nothing is he sitting in the waiting room and not being admitted, or just?
No, I keep saying he has to download something. So he just told me to let you know that he's trying to get on, but it's just he's trying to figure it out right now.
Okay. Again, if he's using either of those directions that I sent, it should not require him to download anything. If you'll text him back and just say, shut everything down and open back up and try again, he should be able to get on.
Okay, I'll let him know.
Okay. All right, now we're going to use our 5-number summary. So we have our minimum value. So up above this number line, we're going to draw in a straight line. So we're going to start with the minimum value, which is 20. We're going to draw the first quartile, which is 28. So we're going to have to approximate that. So here at about 28. So we're going to draw these 5 points, our 5-number summary, in a straight line. Our second quartile is 32.2. So that is approximately here. Our third quartile is at 38. That is approximately here. Our maximum value is at 60. And that is way out here. Now, these 3 dots in the middle is where the box goes. So we're going to draw a box. It's going to connect first quartile to the third quartile. And then the second quartile is going to have a line through it. So that gives us the box part in the middle. The whiskers are going to go from the third quartile to the max, and from the second quartile to the min. And that's our box and whisker plot. And any graph, regardless of what kind it is, should have a title. And so these are speeds. And a construction zone. And we might want to indicate a unit that we're using. So I'm going to put miles per hour there. So we'll know units that we're using. And that's our box and whisker plot. Now let's go ahead and do our modified below, just so you can see the difference. With the modified box and whisker, you're still going to have your box in the same location. So the box part of your modified box and whisker is still going to look the same. The part that is different is going to be the length of your whiskers. So the upper fence went to about 53. The lower fence went to 13. So we actually need to extend our graph a little bit here. Here's 15. And here is 10. And so this whisker goes to there, and this whisker goes to there. And then our extreme value we use as an asterisk to represent the extreme value. So this would be our modified box and whisker versus the regular box and whisker. So does that help give you a view and an example of how to create your box and whisker plots? Sometimes people have not created box and whisker plots before, so that can be something new for people. Any questions? Anything else we need to go over from there? Okay, I hope you found that helpful. All right, we're going into our new topic for today. We've looked at measures of center. We've looked at measures of position. And so our new topic for today is going to focus on measures of variation. Some people also call this measures of dispersion. How do things change? We want to look at how does the data change? Now, some of the easiest measurements to look at in terms of that is range. And you have found this for years. So range is a measurement that's used to find out how much does the data change. And all range is a matter of taking the maximum value minus the lowest value in order to calculate that. It doesn't have a special symbol. You just do that simple subtraction. Now, we've already looked at the IQR when we were doing measures of position, and we just looked at it again when we were doing quartiles, but it is really a measure of variation. And so that is found by taking quartile 3 minus quartile 1 to calculate the IQR. More importantly, we're going to look at calculating a measurement that is called variance. Variance is the average of the square distance from the mean. Variance, however, doesn't really give us a very good measurement by itself. Variance is actually a measurement that is used to help us find the one that's most important, which is called a standard deviation. And the standard deviation is the square root of the variance. It is still telling us how spread out the data is from the mean. That's basically what the standard deviation is telling us. So, the things to remember about variance and standard deviation both. They both help tell us the spread of the data, and they both help determine of a variable's reliability. In other words, is the variable really telling us the truth about how good it is? Now let's look at the formulas. The formulas are going to look very complicated. Now we have one for the population. And then the population standard deviation. Looks like that. So they look very, very complicated, but simply you can just remember that standard deviation is really just the square root of whatever that answer was for the variance. If you just remember whatever answer you got here, you take the square root of it. Now, if you're doing the sample, the formula doesn't change a great deal. It's just the symbols that you're using. Now look at the two formulas. This is mu, which is the mean in population, where we use the X bar for the mean in the sample. That's the only difference. The capital N in the population versus a lowercase n. And instead of this little squiggly symbol, a Greek letter, we're using the letter S. So the actual formulas are the same. It's just the symbols that you're using in the formula. This little symbol, the sigma, makes everything look hard. But anytime you see that little sigma symbol, it just means you're adding up a bunch of stuff. And so a lot of people think that makes it look complicated, but all that's telling you to do is you're adding up a series of values. So then for standard deviation, instead of that curlicue symbol, you're again going to have the letter S and that same formula, but you're taking the square root of it. Or if you just remember that you're taking the square root of that formula that you found, or S squared. That's really all you have to remember about it. So one way to think of this is statisticians use all these formulas to make it look kind of complicated. But if you break it down, it's going to be relatively simple. And that's what I want to try to do for you, is to break it down so that it will be simple for you. If you just look at that formula, you can think it's going to be hard, but it's not going to be hard. Don't let the formula intimidate you. Okay, do you have the formula down? If you have the formula down, I'm ready to work through a problem. Are you ready to go? I know you don't want to, but are you ready? Okay. All right. One of the reasons that we have to look at standard deviation is because, for example, if we were looking at two brands of paint, paint A and paint B, and we were trying to compare them, and we did the average and we did the range, we might not be able to decide which paint is better to buy. We might need more information. And doing the standard deviation helps us look a little more deeply into what's going to be the best brand to buy. So we have a brand of paint. And we've looked at how long it lasts before it starts fading on the exterior of a house. So this is the number of months before it fades. So we have 10 months, we have 60 months, we have 50 months, we have 30 months, we have 40 months, and we have 20 months. So our data is months before the paint fades on the exterior of the house. The first thing that we'd want to do with our data is to find the mean. So how do you find the mean? You add them all up and you divide by how many there are. What is the mean number of months for the paint? Who can tell me that?
35.
35. Now, we want to make a table. In order to help us do that big complicated formula, we're going to do this table in steps. So the first thing that we're going to do is we're going to take our data item and subtract the mean. So we're building the formula. The data item means this data minus the mean. So we're going to do 10 minus 35. So what is 10 minus 35?
Negative 45.
10 minus 35 would be negative 25, right? 60 minus 25 would be 25. Is that right? Or 35? No, I said 60 minus 35 would be 25. 50 minus 35 would be 15. 30 minus 35 would be 5. 40 minus 35, that would be negative 5, excuse me. 40 minus 35 would be positive 5. 20 minus 35 would be negative 15. Did I get that correct? Did everybody get numbers to agree? Now, if you added that column up, what do you get for your total? If you add that column up, what do you get for your total?
Matt is trying to get back in.
Okay. What'd you get for your total? Anyone?
Zero.
0. 0 is correct. All right, before we take off on the next part, how about we take a break? We've been at this a while, so everybody take a break and we'll come back in about 10 minutes. Okay, take a 10-minute break. All right.